Greetings, ladies and gents. Welcome back at Mac Maths and Science Club. Today we are starting off with our finance section. Now, this is actually one of my favorite topic, simply because it's a fun topic, and also because in grade 12, it really gets it gets really interesting. As it become a reflection of the real world. In grade 12, this is where we are actually starting to look at places where we would need to apply this in the real world, or in real life, I should rather say. So I would say it's worth knowing what's happening in the financial world. I would say it's a very fun topic. Just stay with me until the end, where we will be looking at annuities. But before we get into the heavy stuff, today we are going to to do a revision from what we did in grade 11. So you should be familiar with the simple interest formula. So this is actually a simple interest formula. So this is a simple interest formula, where, by the way, P stands for the principal amount, principal amount, or you can also call it the present value, the present value. So this is the amount that you invest, and so this is the money you invest initially. So actually A would be the accrued amount. So this is actually the amount that you get at the end after you have actually invested. So this is the accrued amount. I think actually it's a double C there. So that is a accrued amount. So I stands for the interest rate. So this stands for the interest rate, and most importantly, N does not stand for the for the number of years. We learned that in grade 11. So N actually stands for the number of times interest is added. So this is actually the number of time interest is added. So that stands for the number of time interest is added, not the number of years. So what you need to note about the simple interest formula is that the most important thing I can say is that we must know actually from grade 11 is that the simple interest formula, in this case the value, of course, in the simple interest formula, that the value of the interest, I should rather say, it remains the same throughout the investment time. So in the simple interest formula, so the amount that your money grows by, let's say every month, it remains the same. Now suppose you invest 100 rand, and then they say that they will give you an interest of 50% monthly. So at the beginning of let's say at the end, or rather I should say, of the first month, so your amount will actually grow by 50% of that 100 rand, right? So at the end you would actually have 150. So when you're approaching the second month, it will still grow by that same amount that it grew by initially. So it would actually grow by another 50 rand. So it will be 200 at the end of the second year. And when approaching the third year, again it will still increase by the same amount. So the value that your amount increases by every time remains the same. It doesn't change throughout the investment time. Is the reason for that is simply because the value of the interest in this case is calculated based on what you invested initially. So in the simple interest formula, so the value of interest remains the same. So it remains the same. In this case it doesn't change, but whereby, of course, in the in the compound interest formula, So this is actually the compound interest formula. Now in the compound interest formula, in this case, the value that your amount increased by, it changes over time. So it's unlikely, in the simple interest formula. So in this case, in the compound interest formula, it changes as time progresses. So this you should remember is the compound interest formula. So in this in the compound interest formula, in this case, the value, of course, of the interest, the value of the interest, in this case, this one, in this formula, it doesn't, it actually changes over time. So let's say, suppose again, you invest, that, same 100 rand, and then they say they offer you 50%, of course. Now at the end of the, if the first month, of course, if it's monthly, it will increase by 50% of 100 rand, right? So in this case, it will be 50 rand. So in this case, it will increase to 150 at the end of the first month. So when approaching the second month, in this case, your amount will be 150, right? What's there right now? So in this case, when when it increases, when the second month approaches, let's say at the end of the second month. So in this case, the value that your amount will increase by, in this case, it will no longer increase by 50%, as it will increase by 50% of what is there, currently, what we have right now. So in this case, the value that your amount will increase by, it will be 50% of 150. So that would be when, at the end of the second month, we know that 50% of 150, that would be 75. So in this case, your amount will grow by 75 rand. So it will be that 150 plus 75 rand, which becomes 225. So when approaching the third month, now remember, right now on our balance we have 225, right? So when approaching the third month, in this case, your amount will increase by another 50% of what we currently have now. So in this case, it will be 50% of 225, which I believe is 112.5. So in this case, the value of your interest will increase by actually 50% of 225, which is 112.5. So in this case, it will grow to 337.5. So you see the value of the interest in this case, in the compound formula, it actually changes over time. So the value of the interest changes as time progresses. So that's what you need to know about the compound interest formula. And also, now why is this actually, why does the value of the interest changes? So the reason for this is because the value of the interest, as I've already mentioned, is calculated based on what we have right now. So it is calculated based on what we have currently. So in this case, as your money increases, so in this case, the value that your money will increase by, it will keep on on increasing as as time goes by. And also you should remember that this is actually a depreciation. Specifically, this is actually a simple depreciation, or they call it the straight line depreciation. So this is actually a straight line depreciation. So that's the depreciation. So this is a straight line depreciation, I should rather say. Now what is depreciation? Now depreciation is the loss in value of assets over time, usually because they get used, old, or outdated. Now an example of this would be, now suppose you buy a cell phone for 10,000 rand, and then after 1 year, let's say you decide to sell that cell phone, and then you go to a store and then they say it's only worth let's say 7.5 now. So that drop in value is called depreciation. So we use depreciation to actually show how the value of things like laptops, cars, and even machines, goes down every year, I should rather say. So that's one thing that you must. That's what actually depreciation is. So this is actually the loss in value of assets over time. But now the thing about the straight line depreciation, it actually works as similar to the simple interest formula. So in this case, the value that of course your asset drop by every year, it will remain the same. So if they say, now suppose, let's just take a cell phone, let's say, or an asset rather I should say, that costs 1000 for example, and then they say that your asset would depreciate by 25%. So if it's 1000 right now, so at the end of the first year in this case, it will decrease by 25%, right, of 1000, which is actually 250. So in this case, at the end of the first year, it will drop to 750. So when approaching the second year, now depreciation, it actually happens once a year. So that's what you need to note. So when approaching the second year, so it will still drop by that same amount. So in this case, it will drop by 250. So in this case, it will become 500. And then when approaching the third year, it will still drop by another 250. So in this case, it will become 225, which is left. And when approaching, of course, the fourth year, it will still decrease by that, or depreciates by that same amount, which is 250. So if you were to to draw or to graph what we call the book value of this, so what you would have in actual fact, it's kind of a straight line. Now why is this? Because the value that your asset drop by every time, it doesn't change. So at the end actually it becomes zero. But in real life, an asset can never be worth nothing. So this is not ideal in the real world. So it's actually rarely used. But in this case, the reason why this is a straight line is because the value that your asset depreciates by is actually the same. So if you keep subtracting the same amount, in this case it will drop until to zero. But as where in the reducing balance depreciation, so this is actually the reducing balance depreciation. So this is actually the reducing balance depreciation. So this is the reducing balance depreciation. But in this of course, in the reducing balance depreciation, it also kind of similar, it works on the same basis in terms of the value that your amount will decrease by. So in this case, we know that on the compound formula, in this case it increased, right? So in this case, so on the on the reducing balance depreciation, it decrease. So in this case, for the first year, let's suppose we stick to that 1000. Now suppose, so on the first year, at the end of the first year, your asset would drop. It would depreciate by 25% of 1,000 rand rather. So in this case, it will drop to 750. So when approaching the second year, in this case, it will no longer depreciate by that 250. So it will decrease by actually 25% of 750. So as time goes by, so as you can see, so in this case, the value that your amount depreciates by will get smaller and smaller as time progresses. Because now remember, and also one thing that I must say on the reducing balance depreciation is that the value, of course, of your assets, it doesn't become zero like the straight line depreciation. So if you were to graph what we call the book value of of the reducing balance depreciation, you kind of get this type of graph where actually it doesn't actually become zero in this case. Because now remember, if let's say we have 100 rand, so or let me just take to 1 rand, let me just take 1 rand for for a change. Now suppose, let's say you take 50% of a 1 rand, of course you would be left with 50 cents, right? So when, let's say again, I decide to take another 50% of that, of what's left, in this case of 50%, I will still be left with something, right? So when you take, a certain percent, percentage, of course I should rather say, of something, of course you'll still be left with something, right? So in this case it will never become zero, because let's say you take 50% of something, so another 50% will remain in this case. So it doesn't become zero with the reducing balance depreciation, as you know you've actually. But the thing, what happens is that your depreciation value, in this case the amount that your asset will depreciate by, it will become smaller and smaller, as time goes by. But as in the straight line depreciation, it doesn't change, so it remains the same. So it kind of similar in a sense to the simple interest formula. So this, I'm sure you should know this from grade 11. So I'm sure you did this in grade 11. You did this four formulas. It also, you learned of the conversions between the nominal and the effective interest. Now what I will do is that I will discuss more of this when we are doing our questions. So what I'm going to do is that next I'm going to release a video where we will be focusing on practicing what we did in grade 11. So this will include the depreciation, it will be there, and also the timelines, and also the conversions between the nominal and the effective interest rate. So we're just gonna do a quick I would say a practice based on what we did last year. I would say this is very important. It's in grade 12, because when let's say the work of grade 11, it's kind of uh, we don't do much in grade 12, I should rather say. So if you know your work from grade 11, you should be ready for anything in this case, in terms of, because some of the questions that show up in the grade 12 are kind of what we did in grade 11. So what we're going to do is that we're going to do, I think, 4 questions that we're going to do as for practice. So that's what we're going to do in the next video. So this is the end of today's of this lesson. So this was just talking of the things that we did, no calculation, but on our next video, in this case, we'll do a calculation of the work that we did in grade 11.